Hello student, this is introduction to mechatronics part about sensor topics. In previous class we were seen about introduction of sensors, characteristics of sensor, the division of characteristic of sensors, static and dynamic characteristic of sensors. We were seen varied elements in static characteristic and dynamic characteristics, and in class lecture 2 we were seeing classification of sensors depend on external powers, production of output signals, either digital or analog signals, depend on primary and secondary. And this video is the third part of these topics. This one expresses about selection of sensors and displacement of displacement sensors. Let us start about selection of sensors. This is our today's topics. When you hear this presentation, if you use or taking a short notice, better way to understand in details selection of sensors. We select sensors based on different criteria. One of we will express some of them or most of them. The operation principle in the following parameter needs to consider while selecting sensor for applications. When we select for our projects or other applications, we should considering the operating principles or how our sensor can operate. This one is one of the selection consideration when we select sensors. Availability. Can we get this type of sensor around our shops, or if we can't get the sensors simply, or the maintenance part of, or if we can get for maintenance, this one maybe we can fit the big challenges. The payment option, either if our sensor is costly, we may become difficult to perform or to design our projects. The cost of sensor itself, delivery costs, we should have considered this was for performance figures range. We should have considered the one of the characteristic of sensors also, what we should have to consider when selecting our sensors. This range, power supply requirement, accuracy, hysteresis, and other ones. Let us start the biggest sensor types. This one is displacement sensors. Displacement sensors are basically used to measure movement of an object. This displacement sensor is used to measure the physical quantity called displacements, or these displacement sensors convert the displacement into electrical signals. These electrical signals can be, or this displacement sensor convert the displacement into electrical signals. These electrical signals either resistance, capacitance, or inductance based on electrical outputs. It can convert into these three electrical signals. These three are the basic building block of any electrical signal or electrical building. These three are basic building block of electrics. Based on electrical outputs, displacement sensor can classified into three types: resistance displacement sensor, capacitance displacement sensor, and inductive displacement sensors. This resistance displacement sensor is just measuring our displacement by varying our resistances. Sorry for my sound qualities. Okay, this resistance displacement sensor example are potentiometer, strain gauge, potentiometer, strain gauge. Capacitive displacement sensor measures capacitive elements. Inductive displacement sensor can measure LVDT or linear variable differential transforms or differential transform or transducers. We will see details about these potentiometers, strain gauge, capacitive elements, and inductive displacement. Let us see one by one about. Let's start from resistive displacement sensors. This resistive displacement sensor, one type of resistive displacement sensor is potentiometers. This potentiometer is one of known and widely used type of sensors used to measure the displacements by varying the resistance construction. It consists of resistance elements with sliding contact moved over lengths. We can see from these diagrams or figures where when the resolution is 0.5, we can let us see. This construction is like this. Linear change resistance change with this resistance is convert proportional voltage change in electrical circuit of a sensor. The relation between measured physical. This potentiometer can measure either angular displacement or linear displacements. The output voltage. Okay, let's see this. Their formula are output voltage. The voltage we got in output are we can calculate by using these formulas. K means sensitivity of potentiometer, Vs or supply voltage or initial input voltage times Xx is linear displacement. This one are for linear ones or for graph 1 or figure 2.5a. The output voltage are K or sensitivity of potentiometer times supply voltage times angular displacement. By using these relations, we can get the output voltage. Okay, let us jump into next and widely used type of the displacement sensor or resistivity displacement sensor. These both are measuring displacement by depend on the resistance changes. Then strain gauge. Strain gauge means example of passive. Passive means, as we see in previous classes or lectures, strain gauge is passive. Passive transducer means it needs an external power supply. It doesn't generate by itself as an electric or power supplies. Convert mechanical displacement into change in resistance. This is why we call resistivity displacement. It converts mechanical displacement into resistance. Strain gauge is one of most popular type of transducers. It has got a lot of wide range of applications. It used to measure force, torque, pressure, acceleration, or many other parameters. Sorry. The basic principle of operation of strain gauge is simple. Strain gauge is applied in T metallic, or it assembled or it attached on a metallic. Thus, it changes the resistance of the wire. Let us first investigate what are the factors responsible for change in resistance based on principle of working, mechanical, electrical, and piezoelectric. Mounting boundary strain gauge, we will see in details. Construction of strain gauge. There are many types of strain gauge. Among them, universal strain gauge has a structure that create metallic resistance. Okay, in short, we have laminate film over laminate piece. This metallic resistance foil are attached, or it's attached between the laminate film and plastic film. Between them we can get metallic resistance foil type of electric signals. Electric strain gauge. Types of electric strain gauge are shown in figure 2.7. There are three types of electrical strain gauge: metallic wire, semiconductor type, and metallic foils. We will see the operation of each of them. Strain gauge, tightly bound the measurement. This one is resistance equal to this one is resistivity over length over area. This one is the relation we use. Also, we can apply other change in L R over change in R over R equal with G. G means proportional constant. This E strain gauge. We can understand. Okay. Application of strain gauge. This strain gauge, we use this strain gauge for varied applications such as displacement measurement, force measurement, residual stress, vibration measurement, torque measurement, bending and deflection measurement, compression and tension measurements. We can use this strain gauge also for measuring strain measurement. Strain measurement, okay. Displacement measurement using strain gauge. One of displacement sensor are strain. This means, as we can see from this strain gauge are attached within on these materials. Then when we apply a force, as we can see here, where we apply force, this material moves or it compresses. At this time, our strain gauge measures the change in R over R by using the resistivity over L over the times L over R relations as we see in previous topics. Strain gauge equal resistance equal with the resistivity times length over area. We should have to remember these ones. By using that relations, we measure the resistance of these materials. After this, this resistance converted into our displacements. Okay, our other type of this displacement sensor is inductive sensors. This inductive sensor, best example of inductive sensor is LVDT, linear variable differential transducer or transformer. Linear variable differential transducers work under mutual inductions. If you already take this about machine drive, or about if you have any basic idea about the magnetic inductions. This one is work based on that ones. Its construction is simply based on the Faraday's law. We can see this on the diagrams. There are two wires, primary and the secondary. The secondary one have two sections, V1 and the V2. We can see this between primary and the secondary. The primary one have the self or power generators. This one, and between them we have metallic or cores between these secondary and the primary ones. Working of LVDT. Working of LVDT split the case into three based on iron core position instead drain duration. This one we can simply, if there are no external force, the difference between V1, difference between this one, the difference between V1 minus V2 equal with 0. This one is there is no external forces applied. If there is external forces applied, we get positive. External forces applied tend to left. If this direction is tend to left, our direction become positives. V1 is greater than V2. Then when there are external force and there are left right side directions and the EMF in coil 2 greater than compared with this one is the V2 or coil 2 have greater voltage than V1. We should have to understand this case. If there is no external force, the V1 and the V2 or the voltage induced in V1 is equal with voltage induced in V2. If there are external forces applied, their external forces applied and they tend to move into left hand. If their V1 or voltage induced in V1 is greater than V2, this one left into left side and the result become positive. When V2 is greater than V1, it is tend into right directions and our result become negatives. Applications of LVDT or linear variable differential transform or transducers. LVDT. This LVDT used to measure displacement from fraction. This measure to displacement acting as secondary transducers. This means it doesn't direct measure the displacement of an object. Used device to measure force. It also used to measure force, weight, and pressures. This all is about displacement sensors. We were seen about the applications of LVDT, working principle of LVDT, their construction principle of LVDT, and about strain gauge, application of strain gauge, the relation between resistance and length, area, and resistivity. We were seeing the construction of strain gauge and about potentiometers, linear and rotational strain about potentiometers. Thank you. In our next classes, we will see about force sensors. If you have any questions, write on comment sections. I am ready to ask what you are asking me, and thank you. Don't forget to like, share, subscribe. Thank you.